When I first left Earth, I believed my mission was simple: map the stars, observe distant galaxies, search for signs of life, collect the data, and send it home. Simple, or at least that's what I thought. Because after spending so much time out here, I've started thinking about a different question. Not about what's out there, but about why we're so determined to find it. Why does the universe produce creatures that spend their entire lives trying to understand the universe itself? Think about how strange it is. Out of everything that could possibly exist, black holes, galaxies, nebulae, the universe somehow also produced minds. Minds that ask questions, minds that build telescopes, minds that leave their home planet simply because they want to know what lies beyond it. And the strange thing is, curiosity feels completely normal to us. Children start asking questions before they can even read. Scientists spend decades trying to answer questions that nobody has ever answered before. They've built observatories on mountaintops, placed telescopes in orbit around Earth, landed robots on Mars, and sent spacecraft beyond the edge of our solar system. And we did much of it for one simple reason. We wanted to know, not always because knowing would help us survive. Sometimes we simply couldn't stand not knowing. I've been thinking about that a lot lately, and it made me realize that if I really want to understand where this curiosity came from, I have to go much further back than humanity, much further back than Earth, even further back than the sun. I have to follow the journey of material that eventually became us. Almost 13.8 billion years ago, the universe was in an incredibly hot and dense state. Then it began expanding, and despite the way we usually imagine it, the Big Bang wasn't an explosion happening somewhere inside empty space. There was no empty space outside the universe waiting for the explosion. The space itself was expanding. In the 1920s, Belgian physicist Georges Lemaitre proposed that if the universe was expanding now, then it must have been much smaller in the past. His idea was revolutionary. Then Edwin Hubble began observing distant galaxies and found something remarkable. Almost every galaxy appeared to be moving away from us. And the farther away a galaxy was, the faster it appeared to recede. The universe wasn't static, it was growing. Lemaitre's idea was beginning to make sense. Imagine dots drawn across the surface of a balloon. As the balloon expands, every dot moves farther away from every other dot. No single dot has to be the center. The surface itself is expanding. The universe works in a similar way. And even today, that expansion continues. Right now, while you're watching this, the distances between many galaxies are slowly increasing. But if we travel far enough back in time, we reach a universe that looked almost nothing like the one we see today. There were no planets, no oceans, no forests, no oxygen-rich atmosphere, and certainly no life. The early universe was remarkably simple, mostly hydrogen and helium with tiny amounts of other elements. For hundreds of millions of years, there were not even any stars. Just an expanding universe and darkness. But darkness doesn't mean nothing was happening. Gravity was already at work. Slowly, almost unimaginably slowly, gravity began pulling enormous clouds of gas together. It didn't happen overnight. It took millions of years, then millions more. The clouds became denser and hotter until deep inside them, the pressure became powerful enough to force hydrogen nuclei together. And suddenly, the universe had its first stars. For the first time, there was light. Imagine witnessing the first sunrise in a history of existence. Not a sunrise over Earth, not a sunrise over a planet, the first sunrise anywhere. And those first stars didn't simply illuminate the universe, they began changing it. Inside their cores, nuclear fusion transformed hydrogen into helium, releasing enormous amounts of energy. In stars like our Sun, this process continues every second. Roughly 600 million tons of hydrogen are converted into helium every second, and a small fraction of that mass becomes energy. That energy eventually travels outward from the Sun and, after an 8-minute journey through space, reaches Earth as sunlight. Which means that every sunrise you've ever experienced, every tree that has ever grown, every plant that has ever turned toward the light exists within a chain of events that began inside a star. And the deeper we look into that chain, the stranger it becomes. Because these stars weren't just producing light, they were producing the ingredients for everything that would come later, including us. For most of its life, a star exists in a delicate balance. Gravity is constantly trying to pull it inward, while the energy produced by fusion pushes outward. For billions of years, those forces can remain remarkably stable. But eventually, every star begins to run out of fuel, and when a massive star reaches the final stages of its life, that balance can collapse almost instantly. The star begins creating heavier and heavier elements in its core. Hydrogen becomes helium. Helium can become carbon. Carbon can lead to oxygen and other heavier elements. The process continues until the core eventually becomes dominated by iron, and iron changes everything. Unlike the elements produced before it, fusing iron doesn't provide the energy a star needs to support itself. So, when the nuclear reaction can no longer hold gravity back, gravity wins. The core collapses in a fraction of a second. Temperatures soar to billions of degrees. Matter is compressed under unimaginable pressure. And then the star explodes, a supernova. For a brief period, a single dying star can shine with the brightness of an entire galaxy. It sounds like pure destruction, but that's where the story takes a remarkable turn. Because the death of a massive star can create and distribute many of the elements needed to build planets and eventually life. In the year 1054, astronomers in China recorded a brilliant guest star that remained visible for weeks, even during the day. Today, we know its remains as the Crab Nebula. What those astronomers saw was the aftermath of a star that had lived, transformed its surroundings, and finally died. And scientists eventually realized that this wasn't an isolated phenomenon. Stars are not simply giant balls of light. They are cosmic factories. Fred Hoyle, along Margaret Burbidge, Geoffrey Burbidge, and William Fowler helped establish our understanding of how stars create many of the heavier elements found throughout the universe. In other words, the universe wasn't born with everything it needed. It had to manufacture those ingredients over time. And the stars did the manufacturing. The oxygen in your lungs, the calcium in your bones, the silicon in your electronic devices, and the iron flowing through your blood. They all began their journey inside ancient stars. Some of the material that makes up your body was created billions of years before the Earth even existed. I find that difficult to comprehend because when you look at your own hands, they feel like the most familiar things in the universe, but the atoms inside them have lived through a history that is almost impossible to imagine. They were forged inside the stars, scattered through space, mixed into enormous clouds of gas and dust. And eventually gravity gathered that material together, once again. A new star formed, and around that star leftover dust began colliding and sticking together. Tiny grains became rocks, rocks became larger bodies, and over enormous periods of time, those bodies became planets. One of them was Earth, but Earth wasn't immediately the blue, peaceful world we know today. It was violent, volcanic, molten in places, constantly bombarded by asteroids. Its atmosphere was nothing like ours. There were no forests, no birds, no cities, no people, and yet the essential ingredients were already there. The atoms created by ancient stars had found themselves on a new world. And then something happened that would completely change the story. Chemistry became more complicated. Some molecules began interacting in ways that allowed increasingly complex structures to form. Eventually, somewhere in Earth's ancient oceans, chemistry crossed a remarkable threshold. Matter began producing imperfect copies of itself. Those copies changed. Some survived better than the others, and over immense spans of time, natural selection transformed simple life into increasingly complex forms. Life learned to use sunlight. It learned to move, to hunt, to reproduce, to adapt. And eventually, it learned to wonder. That may be the strangest transformation of all, because the universe had spent millions of years creating stars and planets. Now, for the first time, it had created something that could look back at the universe and ask, what am I looking at? Think about your brain for a moment. It feels completely different from everything around you. A rock doesn't seem to have thoughts. A mountain doesn't wonder where it came from. A star doesn't appear to question why it exists. And yet, your brain is made from ordinary matter. Carbon, hydrogen, oxygen, nitrogen, calcium, iron. The same basic ingredients that exist throughout the cosmos. There's nothing in your body that had to be imported from somewhere outside the universe. Every atom belongs here. And that's what makes this story so strange. The same universe that began with mostly simple elements eventually produced matter capable of thinking about its own origins. For centuries, humans imagined ourselves as observers standing outside nature. But science has shown us something much more interesting. We never stood outside the universe. We have always been part of it. Every heartbeat, every memory, every equation, every poem, every telescope we've ever built, every spacecraft we've ever launched, all of it is the universe rearranging its own material. Astronomer Carl Sagan famously described humanity as a way for the cosmos to know itself. And perhaps that idea is more profound than it first appears. Because look at that sequence. First, there was hydrogen, then gravity gathered it into stars. Stars created heavier elements. Those elements became planets. Planets developed chemistry. Chemistry eventually produced life. Life produced nervous systems. Nervous systems produced intelligence. And intelligence produced curiosity. At every stage, something more complex emerged from what came before. Nothing had to step outside the laws of physics. The universe simply kept building, and eventually, it built something that could ask questions about itself. That's why I keep thinking about curiosity. Maybe it began as an evolutionary advantage. Our ancestors needed to understand their environment, where food was, where danger was, when the seasons would change, how to navigate, how to survive, but eventually, curiosity grew beyond survival. We started asking questions that had no immediate practical purpose. What are the stars? How old is the universe? What is inside a black hole? Are we alone? Why does everything exist at all? And we kept asking. We built observatories, invented mathematics, launched the space telescopes, sent probes beyond the solar system. We walked on the moon. And now we are building spacecraft capable of carrying humans deeper into space. Not because we know exactly what we'll find, because we don't. Maybe that's the part of what intelligence does. It explores, it asks, it searches beyond the edge of what it already understands. And perhaps that's why I no longer think of humanity as something separate from cosmic history. Maybe intelligence is simply one of the ways the universe explores itself. Because think about the journey of the atoms inside you. They existed long before Earth. They were created inside ancient stars. Some were scattered through enormous explosions. They wandered through the galaxy. They became part of the planets. They became part of the living organisms. And eventually they became you. For billions of years, those atoms simply followed the laws of physics. Gravity, electromagnetism, nuclear forces. They had no idea where they were going. And now, those same atoms are looking at the stars, thinking, remembering, wondering, asking why. Maybe the universe didn't begin with a purpose waiting somewhere at the end. Maybe purpose is something that emerges along the way, something created by conscious beings. Every child who looks at the night sky and asks a question, every scientist who spends decades chasing an answer, every engineer who builds a better telescope, every explorer who travels farther than anyone before them. Each one adds another sentence to a story that began almost 13.8 billion years ago. When I first left Earth, I thought my mission was to observe the universe. Now, I'm not so sure. Perhaps my mission is to help the universe understand one tiny piece of itself. And perhaps that's true for all of us. Not because we're the center of existence, but because we're one of the ways existence can look back at itself. So, if you're watching this from Earth, go outside tonight. Look up. Those stars are not strangers. They are part of your story. All of it has a story that began billions of years before you were born. The universe has spent almost 13.8 billion years becoming what it is, and somehow you became one of its newest pages. So keep asking questions, keep looking, because maybe every time we ask the universe a question, the universe is, in a very small way, learning how to understand itself. This is Justin, Captain of the Black Star.